Hi friends, how are you? Hope you all are fine. Welcome back to the another section, right? Today we are going to start a new chapter. Its name is Squares and Square Root. This is our 6th chapter, right? So first of all, the chapter name Squares and Square Root. From here itself, we can say what we are going to learn. Yes, this chapter we can divide into two sections. The first section is squares of a number. And the second section is square root. And here in this chapter we are going to learn detailed about how we can find out the square of a number. And the second section, what is square root of a number and how we can find out the square root of a number in different methods. So let us start. First one, the very first part, square of a number. Yes, we know a square of a number means, yes, when we multiply a number itself, we will get another number. We can say that number, the new number is a square of the first number, right? So here is a square table, right? The concept is very clear here itself. See, the side of a square, we can take it in centimeter, 1 centimeter, then area of the square, we can say what that should be side into side, that is 1 into 1, that is 1 square. So we can say if the side of that square is 2 centimeter, its area we can say side into side, 2 into 2, yes, that is 4. So we can say, we can write it as 2 square. So how we can represent this? If the side is 1 centimeter, we can write 1 square, we can represent as like this, 1 raised to the power 2. So it's read it as 1 square. What does it mean? That means 1 into 1. Multiply this number twice or multiply the same number with that number once, right? Twice we are multiplying. So we are getting what? We are getting 1. So if you can say 2, side we are taking it as 2, then we can write 2 square as 2 square in this way. What does it mean? Yes, this means 2 multiply with 2. Got it? So we will get 4. So we can call it as 2 square equal to 4. So just suppose if the side of the square is 9, then how we can find out the square or the area of that square? Side into side. In the same way, in this number square, we can find it as, or we can write it as 2 raised to the power 9 raised to the power 2. That means 9 square. What does it mean actually? So that means 9 into 9. That will get 81. So we can say 9 square equal to 81. This much only the square concept. If you are getting one number and they are asking to us find the square of that number, we just need to multiply that number, multiply once that number with the same number, right? So here it is a number obtained when a number is multiplied by itself. It's called a square. Okay. So we can generalize these things as, is take that number as a. Then if the number is a, then we can write its square as a square, right? What does it mean? That means that number multiplying with that number itself. So this is a concept of square. Hope you understood. Let us move to next section. Here is a square table. It's very important. We have to learn this square table. Square table means this much only. Number 1, so square 1 into 1. Number 2, 2 into 2, 4 we'll get. And this way we can find out the square table. So here is square table. So 1 square is 1, 2 square 4, 3 square 9. How we are getting that? Yes, 3 into 3 9. 4 square 4 into 4 16. Like that way we can make 1 square, this square table, 1 into 1, 2 square, yes, that is 2 into 2, that is what? 2 into 2, that is 4 we are getting. 3 square, what we are getting? 3 into 3, we are getting 9. 4 square, that means 4 into 4, we are getting 16. 5 square, yeah, that is 5 into 5, what is the answer? 25. So this is called a square table. 10 square, we can say 10 into 10, that is 100. Well, hope you understood what is square table. Well, now we are going to learn some properties of the square number. Properties of square number. So, what are square numbers? Yes, the square numbers are, we know, we can list the square numbers as here 1, yeah, then 2 square 4, then what's next? 3 square 9, next 4 square 16, the next 5 square 25, then 6 square 36, 7 square 49, 8 square 64, 9 square 81, 10 square 100, 11 square 121, and so on. These numbers are called square number, or we can call it as perfect square number. Perfect square number. These numbers are called perfect squares. These numbers are called perfect squares, or we can call it as square numbers. Well, now we are going to learn some properties of these square numbers or perfect squares. Well, the very first property is that all square numbers end with 0, 1, 5, 1, 4, 5, 6 or 9 at its unit place. That means when we take any square number, any perfect square, it's only end with the digit this. That is the very first property, right? And the second property, the square number can only have even number of zeros at the end. Suppose we are getting a number 100. We know this number is end with the 2 zeros, right? So this is 2 zeros. Therefore, we can say even number of 0. Even number of 0. If it is a square number or perfect square, definitely it ends with even number of zeros. Okay. Then just take another example. Here it's another number. How many zeros? It's end with 0. So what we have to do? We have just count. Since it's end with 0, we have to count how many zeros. Yes, here get 3 0. So we can say, we can conclude that this is not a perfect square number. This is not a perfect square, or it's not a square number. Why? Because it's end with the odd number of 0, because 3 zeros are there. But here it is even number of 0. If the number is end with 0, we have to check how many zeros are there. If the number of zeros is even, we can say there is a chance it is a perfect squares, or it's a square number. Got it? And now what's the next property? The number end with the number ending in 2, 3, 7 or 8, it's now a perfect square. For example, this. Okay, another property. If you are getting a number and that number is end with one of this digit, any one of this digit, we can say that is definitely it's not a perfect square number. See, what are those digits? Yes, 2, 3, 7 or 8. If the number is end with this digit, we can say that it should not be a perfect square. So for example, here we are considering a number. Is there any chance this become a perfect square? No. Why? Yes, just now we have learned the property, a number ending with the 2, 3, 7 or 8 is never a perfect square. So when we look at this number, its unit place is 7, unit place digit is 7. So directly we can say that it's not a perfect square number. The reason is all the perfect square numbers should not. All the perfect square numbers end with the first property we said 0, 1, 4, 5, 6 or 9, or in other words, a number end with these digits is not a perfect square number. So we can conclude it's not a perfect square number. So what about the next property? What is next property? Yeah, that is this one. A number end in 0, 1, 4, 5, 6 or 9 may not necessarily be a square number. In the first property, all square numbers end with this, we said. Does it means all the numbers end with these digits are perfect number? Never. That is only this property says. What is that? The number end in 0, 1, 4, 5, 6 or 9 may not necessary. It is not necessary. It may be a perfect square number. Let us consider some example. See here, they have given the example 20. Yes, 20 is a number. Well, it's end with 0. By using this property, can we say this is a perfect square number? Never. And actually this property says what? All the square numbers end with this digit. But that doesn't mean all those numbers end with this digits are perfect squares. Well, that only this property says. So we can say it's not a perfect square number, right? It's not a perfect square. Well, and another example. Yes, 81. Check it. Yeah, it's end with 1. See? Here we know 9 into 9. Yes, we are getting 81. This digit is end with 1. So we can say it's a perfect square number. But 71. Let us consider 71. This 71 end with 1. Even digit 1. But it's not a perfect square number. Okay, but this is a perfect square number. End with 1. But this is not a perfect square number. End with 1. That only this property says the numbers end in 0, 1, 4, 5, 6 or 9 may not. It is not compulsory. Well, it is not mandatory. All those numbers are end with this digit should be a perfect square. Well, but maybe sometime it may. Okay. So the next property, the squares of even numbers are even. Yes, that's quite interesting. It's a very simple property, right? The squares of even numbers are even numbers. When we consider any even number, its square should be an even number. See, 7 is an even number, its square also even number. Well, see, another 12, it's an even number. What about its square? Yes, 144, you said it. Yes, it's an even number. The same way, the squares of odd number are always odd. So let us consider 5. It's an odd number. Its square is what? Its square is 25. Yes, again it's a odd number. See, 11, it's odd number. What about its square? 121. So it's again odd number. So this property is clear for you, I think. The squares of even numbers are always even and the squares of odd numbers are always odd. Well, let us move to the next property. Well, what does it say? Yes, can you read that? Yes, the number end in an odd number of zeros cannot be become perfect square, for example. Okay, we already discussed that. If the number is end with 0, if a number is end with a digit 0, for checking whether it is a perfect square number or not, what we have to do? We have just count the number of zeros end with it. If it is odd, we can conclude it's not a perfect square. If it is end with even digit, even number of zeros, there is a chance. Okay, so that is only this property says. Well, let us move to next section. Here is another property. The difference of squares of two consecutive natural numbers is equal to the sum. What does it mean? The difference, we know the difference. The difference of what? The squares of two consecutive natural numbers is equal to the sum. So to check that, we have to take any two consecutive integers. Let us consider 4 and 3. Yeah, we know these are two consecutive integers, right? Let us check what is 4 square. Yeah, 4 square we know that is 16. And now consider 3 square. So what is that? That is we know 9. And what about its difference? What about its difference? Difference equal to, yes, that is, yeah, that is 7. Okay, and what does this property says? The difference of squares of two consecutive natural numbers equal to the sum. Yeah, what about its sum of 4 plus 3? Yeah, that is 7. Now check the difference of the squares of two consecutive integers, that we are getting what? 7. That should be same as the sum. Yeah, the sum of these numbers is 7. 7 we are getting. Hope you understood this property. Yes, let us move to next. Yes, it is quite interesting pattern. Adding odd numbers. Check here. Consider this pattern. See, one odd number. Well, its square, so 1 itself. Now add first two odd numbers, that means 1, next odd number is 3, so 1 plus 3, yes, sum of first two odd numbers, that is 4. Yes, we can connect it, relate it as 4 as 2 square. Well, next 1 plus 3 plus 5, yes, that is what the sum of the first three odd numbers. What's the result? When we are adding this, we are getting 9. How we can connect this? Yes, 9, we know that is 3 square, we can connect it like that. Now the next one, 1 plus 3 plus 5 plus 7, what we are getting? Yes, when we are adding, we are getting 16. Actually, what does it? Yes, this is the sum of first 4 odd numbers. Yes, so we can connect it as 4 square. So I think you click what this pattern follows. This is the sum of the first 1, 2, 3, 4, 5. The sum of the first 5 odd numbers. Yes, we are getting 25. That we can connect. So we can generate an equation from this pattern. What does it mean? The sum of the first n odd numbers is n square. Well, the sum of the first n odd numbers is n square. Let us consider 1 plus 3 plus 5 plus etc. plus 49. Yes, how we can find out its result? So yes, we know this is the sum of the odd numbers only, right? First here it's up to 49. Up to 49, how many odd numbers are there? How many numbers are there? Yes, we know that is 20. There are 25 odd numbers. So its result should be 25 square. So 25 square, how will we find out? Yes, that is 25 625. Well, so this way we can easily find out the sum of the first n odd number. That is only this equation says. Hope you understood. Well, now the next property, the next concept, Pythagorean triplet. What does it mean? A triplet means, you know, 3, right? There should be 3 numbers. So the Pythagorean triplet, we have learned that Pythagorean's theorem. Yes, here it's a right angle triangle, you know. It is hypotenuse, this is altitude, this is base. What does the Pythagorean theorem says? Yes, the Pythagorean theorem says this square equal to hypotenuse square, that is equal to base square plus altitude square. Well, so when we write the numbers here, if we are taking this as 3, this as 4, this should be 5. Why? Yes, we can say, see, let us check. What about 5 square? 5 square, yes, that is 25, you know. Then what about 4 square? 4 square equal to 16, we know. And what about 3 square? Yes, 3 square equal to 9. Here we can find out a relation. What is that? Yes, 16 plus 9 equal to 25. That means here it is 4 square plus 3 square equal to, yes, here it is 5 square. If we can find out a numbers in this way, we can connect 3 numbers in this way, we can say those numbers are Pythagorean triplet. Well, so we can say 3, 4, 5 is a Pythagorean triplet. Why? Because we can write it as 5 square equal to 4 square plus 3 square. Well, so like this there are so many Pythagorean triplets are there. Well, so how we can find out the Pythagorean triplets? If we are asking like this question, what does this question says? Write the Pythagorean triplet whose smallest number is 8. So let us check how we can find out. Yes, here the Pythagorean triplet, here is an equation. We can get Pythagorean triplet by using the general form. Yes, a 2m comma m square minus 1 comma m square plus. Yes, the Pythagorean triplet always in the form of 2m comma m square minus 1 comma m square plus 1. It's very important. If you are taking any Pythagorean triplet, it should be in this form. Well, so let us check how we can solve like these questions. What's question? Write the Pythagorean triplet whose smallest number is 8. So we can from here how we can solve this one. Yes, well, to find the Pythagorean triplet, here it's given the smallest number as 8. So smallest number they have given us 8. Let us assume it as 2m. So we can write 2m equal to 8. Got it? From here we can find the values of m. Value of m. Yes. What does it say? 8 divided by 2, that is 4. We got the value of m as 4. Well, now we need to find out this and this. Well, so we can find out the second number, m square minus 1. So what is m? The value of m we got 4. Therefore, this is as 4 square minus 1, that is equal to 16 minus 1, that is equal to 15. So the second number we got. Then what about third number? Yeah, that should be m square plus 1. 4 square plus 1, that is 16 plus 1. We are getting this number as 17. So we can say the Pythagorean triplet are 2m comma m square minus 1 comma m square plus 1. Yes, we got 2m values as 8, not 4. 2m, that is 8, smallest number. The next 15, comma 17. These are the Pythagorean triplet. Yes, did you get it? Let us consider some other example also. See, here is a question. So what is that? Yeah, find the Pythagorean triplet in which one number is 12. Yes, they are asking. We have to find out the Pythagorean triplet. One of the number is, or the smallest number in which one number is 12. No, not matter. We can take the smallest number as smallest number or one number as 12. We need to find out other two numbers in that series, the Pythagorean triplet. Well, so what we can do? So we can write first it as the Pythagorean triplet are 2m, yes, you say m square minus 1 comma m square plus 1. We know these are the Pythagorean triplet. So first we have to take 2m as 12. One number is 12. From here what we have to do? From here we have to find out the value of m. Yes, m equal to 12 divided by 2. What will get? 6 we are getting. Well, now we have to find out the second number and third number from here by using this formula. So we can write second number as m square minus 1. So value of m equal to 6. Therefore 6 square minus 1, that is 36 minus 1 should be 35. The second number we got. What about third number? That should be m square plus 1. So 6 square plus 1 we are getting 36 plus 1 we are getting it as 37. Now we can write the numbers are the first one not 6. What's the first number? 2m. 2m means 12. So 12, the Pythagorean triplets are 12, 35 and 37. These are the Pythagorean triplet. When we calculate this 37 squares as, we can write it as 37 squares should be same as 35 square plus 12 square. It should be same. Okay, that's why we can say these three are Pythagorean triplet. Well, hope you understood today's section. Thank you.